So one of, I think, the most powerful ideas around local first is this idea that you can eliminate APIs and microservices from your stack. You have application code, it talks to a local embedded database, data syncs in the background, and you just don't need all of these REST APIs, CRUD services. It's like it's much simpler, it's operationally simpler, it's a better user experience, etc. And I was thinking about coming for this talk, for this meetup now, and remembering coming to the first one last year, which for us, I remember coming with Walter, and it was such a pleasure because we had been talking about local first for a whole bunch of time before that, and we'd been getting a lot of feedback from people going, is local first really a thing? Do people understand what the words mean? Do developers know what it is? And then it was really coming to the meetup, I think it was 18 months ago here in Berlin, that for the first time met a whole room full of people who actually were really into local first and knew what the words meant and were building on it. And I think we were having such a good time that I do remember, Walter, that we were probably two of the last people to leave. So we did the meetup, there were drinks after the meetup, we went to the bar, I think maybe the bar had shut, and there were 4 of us left outside the bar because we didn't want to go home. And I remember talking to Andreas Klinger, so I don't know if Andreas is... He can't make it today. He has more important things to do, defending Europe's technological honor. But we were talking as like the last people outside the bar, and this was exactly the perspective that he was giving. He was sort of arguing with real clarity and force, like, this is the proposition to focus on for local first. Eliminate APIs. And so coming back the second time, I thought I would take a totally different perspective. And instead of talking to you about that, I would talk to you about how you can build local first applications using your existing API. Because one of the things that we're doing with Electric is we are trying to make a platform which is, in a way, an on-ramp for mainstream adoption of local first. And this sort of power of eliminating your APIs is actually such a big shift. Like, it's a real paradigm change. And actually, like, for developers who are looking to get stuff done, having that kind of big paradigm shift is a real barrier to adoption. About 15 years ago, this is a bit of a confession to make, for a while I got a bit into the discipline of service design. So I was working in London at the time. I was just sort of transitioning out from working for a digital agency to working for myself as a freelancer. And I'd been working for these sort of cool design companies, so people like IDEO and Made by Many. And so it was quite beguiling, some of these ideas around how you could take stuff from strategic design and sort of civic service design and apply those to building digital products and services. And so I got quite into this. I remember once I flew out to Uppsala in Sweden, and it was just insanely cold, and it was this sort of academic service design conversation. So it was so cold that London had been shut down and just iced out, couldn't get to the airport. So I lost a day getting there, and when I arrived it was about -25. And I was kind of 3 kilometers outside of Uppsala in sort of ill-fitting British clothes, and waiting to go into these things, and literally my face was freezing. I had like icicles in my nostril. And there was a guy who was there with me who we kept sort of traipsing around these events with, and he introduced me to a really interesting book, which is what I wanted to talk about now. So this book is called Where Stuff Comes From, and it's a kind of seminal service design text. And basically it talks about how pretty much everything in today's kind of products and services and economy is interconnected. And the example that they give in this book, their sort of favorite example, is what they call the humble toaster. And that's the best image I could get with that prompt into AI. So there is our humble toaster. And the point of this example with the toaster is you look at a toaster, it's a pretty standard like product. It's 10, 20 euros in the shop. It's like standalone, you make toast in the morning. But actually, if you look at it through this sort of service design lens, or the lens of this book, it is actually integrated with pretty much everything else in the entire economy. And so now, for some audience participation, what I wanted to do was a kind of typical service design exercise. Now, with a service design, you have to use a whiteboard, Post-it notes and Sharpies. Now, I don't actually have those, so what I thought I would do is I would have an imaginary whiteboard. And then I'm just going to turn the page over. And what I'm going to do is I'm going to write toaster in the middle of the whiteboard page. And what I would like you to do is tell me, what do you think a toaster integrates with?
Electricity.
Okay, one at a time. Electricity, was that? Yeah. Okay, so we've got electricity. So what? There's a plug that comes out. It plugs into electricity. So where does the electricity come from?
Power source. Plant.
A power plant. So what kind of power plants? Also, okay. Okay, we've got nuclear, we've got hydro, we've got coal. Okay. Not in Germany. Okay, which one should we take? Let's take hydro. So what is a hydro power plant made out of?
Copper. Concrete.
Concrete. Where does the concrete come from?
From the soil.
The soil. Who digs it up? Who finances, etc., right? So you follow this through. So give me another aspect that's not the power.
Toast.
Toast, exactly. Or, I mean, that's what comes out.
Well, in Germany, we call it toast.
You call it toast. Ah, is that like sliced bread? It's called toast. Bread, okay. So you get bread, right? So what type of bread do you get? Wheat. Nice, yeah, you get the ingredients, so you get the agriculture producing the wheat. So anyway, we could go on, right? But you kind of get the idea. There's like they talk in the book about like sliced bread and how sliced bread comes in a certain shape to fit the toaster, and it's sold in supermarkets and it's packaged in plastic, and where does the plastic packaging come from, etc. And you see that you just kind of go out to like, well, who finances the supermarkets and where do they get their stuff from and who runs the logistics, and what you think is a standalone product is actually just integrated with like all sorts of aspects around it. And so next, in my imaginary whiteboard, what I want to do is a fresh sheet of paper, and instead I want to write API. And I'm not going to do the same exercise, because I don't need to, because we're a room full of software developers, right? We just all had 5 different ideas of how your API is integrated into other stuff. So it's integrated into it talks to your database. You deploy it in a certain way. It has like packaging, it has monitoring tools. It's like Sentry will show you request logs, and it understands request parameters and so forth. And not just like the tooling, but also like personally as a developer, like I'm an Elixir developer. I would say I'm a Phoenix developer. It's like, it's my skill set, it's my experience. I know how to debug an API. It actually comes all the way to my identity as a person. It's like I am a Phoenix developer. So basically this concept of ripping out your API, you see like actually you'd have to break all of these connections with all of the other things that it was integrated with. And that's the barrier that holds back people from adopting local first, if the paradigm of local first is to get rid of that. And so basically that's why today what I wanted to talk about was this concept of how can you move towards local first and build local first applications, not throwing away your API, but actually using your existing stack. And so that's what I'm going to just jump into and show with some code now. The first thing I wanted just to talk about a bit is the role of Electric. So moving to local first, one of the things that you do need to adopt is you move to this model of having local data inside the application. And the challenge with that is if you just have the local data without some mechanism of keeping it in sync, you get stale data. And so that's why you need some kind of sync technology as a kind of precursor for it. And in a sense, that's the sort of change that you need to make to your stack, which is this like swapping out data fetching for data sync. And obviously, if you know Electric, you know that's basically what we do. We're a Postgres sync engine. Like this time last year, we were building much more ambitious integrated end-to-end stack, like more like a project like Jazz, for example, whereas since we've consolidated down on just doing read path sync. So we do read path sync out of Postgres into local apps with partial replication, and we keep that local data in sync. And then, like, there's a couple of key things just to know about that, which will help you understand what we're just going to jump into. Let me just put this down. So the first one is that it's just HTTP. So often when you have this type of sync tech, you think like optimized binary protocol over WebSockets. We deliberately engineered the sync engine on an HTTP protocol, where actually it's also just HTTP and JSON. partly because that way we can leverage CDN infrastructure to scale out the data delivery, but also it allows you to just reuse aspects of an HTTP stack, so middleware, proxies, etc. A whole bunch of that existing tooling which works with like your existing API, we might have as part of a kind of an API stack, you can bring and use with this API because it's HTTP. Closer. I can try. And so, I mean, I'll jump into it because there's a bit of code to show, but there's then a couple of things that I wanted to particularly highlight. And so, because it's an HTTP API, again, if you think about these type of sync systems, typically what happens is, because you lose that kind of back-end layer, for things like authorization, what you need to do is codify what you used to have as like API authorization into some kind of database rule system. Whereas if you're syncing over HTTP, you can actually just use the same kind of middleware to authorize access to the data. And again, like, just to understand the API here, so it's an HTTP API. We literally have like this get shape endpoint. So you literally just make a request to this endpoint and you put the shape parameters into the URL. So all the information about which data you want to sync is available in the request. And so you can just authorize the request based upon the information that's in the request parameters. And so, yeah, the two things I wanted to dig into is, first of all, for this thing about like, how do you do data security or authorization with local first? And actually, if you're syncing data like this, you can just do it using your existing API tech. And then the other one is writes, right? So because we don't do write path sync, so like with a system like this, how do you do writes? And what I've got to walk through is I've got 4 different examples of ways in which you can do writes, 3 of which are proper local first systems just using your existing API tech. And they sort of build up in complexity. So what I'm going to do is just switch over to some code here and kind of show this. So I'm just going to jump into the source code for a couple of these examples. So what I was going to show first is just, it's really quite simple, but is one of our authentication examples. And so this, like we have a couple of patterns. One is where you just put a proxy in front of Electric. And then the second pattern, which we call gatekeeper, is where you have an API endpoint which generates a token which a proxy then validates. And so what that pattern does in particular is, if you think about like what you typically do with authorization, sometimes you do things like query the database or call out to an external authorization service. If you do that kind of on the hot path of like every kind of request to sync data, it's actually quite a lot of logic. Whereas if you do it once, and then you can generate not just an authentication token, but a shape-scoped authentication token that says, yes, this token grants access to this particular data, then you can do that slightly long-running call out to a service, call out to a database just from your normal API, generate a token, and then that token can be validated by any proxy. And again, that proxy can be, for example, it could just be your API, which is proxying to Electric, or you could use something like Nginx or Varnish or Caddy, like a standard reverse proxy thing, which also then adds some caching in front. Or if you're serving the data through the CDN, then your proxy might want to be an edge function which can run in front of the CDN. So this kind of pattern here just basically shows all of that. Can you read the code okay? So this is a Phoenix application. So it's a sort of old-fashioned back-end web framework, right, API. We have a middleware pipeline that's doing the authorization, and we just have a couple of endpoints. So the first endpoint here is the gatekeeper endpoint, and basically it uses this authenticated headers to just generate an authorization header with a bearer token in it. And that bearer token is basically shape scoped. It's kind of generated from your shape parameters. And then in this example here, like that's all you maybe have to have within your API. But for an example, we also have an endpoint here of then doing the proxy for that. And just to show you the middleware pipeline, so basically with the gatekeeper one, what it does is say, okay, get me the authenticated user and then authorize the shape access. And so we basically just have a middleware pipeline that kind of does like stuff going, is it authorized? And then in this case, we're just authorizing for any dummy user because it's an example, but this is where you could just put arbitrary logic. This is like a standard HTTP middleware thing where you can do what you like. And then when we're verifying the token, it's literally just kind of, again, authorizing that the token matches the request parameters. And so if we use this, so if I just kill that, I can just basically, first of all, if I just hit the proxy endpoint to get the data, it's unauthorized because we don't have an auth header. If I then, here I'm now going to call the gatekeeper endpoint and say, hey, I want to sync the items, and you would provide authentication credentials with that. That then generates out the auth token here. If I go, I'm just going to write this to a environment variable, and now I can do, I can hit that proxy endpoint to sync the shape data, and it comes through because it's authorized. So it's pretty straightforward stuff, right? I mean, sorry, you can't see it very well, but this is a 200 response, and there's no data in the table, so you just get an empty list back. But basically, it's just very, very standard kind of token-based auth. And this example here is just running all through this Phoenix application. If I jump out of this, I can show you, for instance, this is like an example of doing the same proxy validation in a caddy file. So here, caddy has a standard JWT auth module, and here we extract out the shape definition from the claims in the JWT token. And then here we have a little bit of CEL logic to go, does the shape claim match the data in the request parameters? And that's what basically authorizes the access. And there's another example in here for just running the same logic in an edge worker. So this is like a super base edge function, and it just does the same logic in Node. So you can see this pattern of like your API generates the auth tokens and your proxy controls access to the data. And then the key thing is you don't need to codify your auth logic into a database rules system. So that's the kind of auth example. To jump into the writes example now, so this is this like, okay, so if you're doing read path sync, how do you use your existing API to handle writes with a local first application? Now, the first example here is the simplest pattern, which is just online writes. So you're not doing offline kind of particularly proper local first. You maybe have local first on the read path, so you have the data locally. Some applications don't do writes very often. This can just be a sort of starting point. So this is a React component. And we have a use shape hook, which is how you sync data into a React component with Electric. This is the read path sync, just coming in here. And then basically, if I scroll down a bit, show you the template, it's a standard to-do app. So we just have like a list of to-dos. You can click to update the to-do, you can click to delete it, and a little form at the bottom to add one. And then if you just see the handler functions for those here, it's very simple. You just basically take the data and post it to the API. This is just this is like a resilient fetch client, but it's just literally fetch. And then I'll walk through the patterns, and then I'll kind of show you it running and the behavior. So that's like a starting point that does allow you to basically build an application with writes on read path sync, but obviously it's not really local first writes, and it's not offline capable. So the next pattern just layers on optimistic state. So the idea is that you can do a local offline write, you optimistically display it to the user in the browser, and then you try and send it to the API in the background. And the latest React release just released this use optimistic hook, and all we do here is basically there's a concept of a transition, which again is a built-in React feature. We sync data in exactly the same way. And then here is the thing where you use this use optimistic hook that basically merges any local optimistic state on top of the synced state. And that pattern, by the way, is actually very powerful, the pattern of basically syncing into an immutable store and then having local mutable state which you can apply on top of it, instead of syncing into like a unified mutable store, which is then much harder to kind of reason about and deal with various edge cases. So this use optimistic state hook just sort of does that for free. And then it provides a function for you to write optimistic state, and then when you do that, this callback runs, and this is just the like, if it's an insert, add it to the list, if it's an update, patch the properties, if it's a delete, delete it. And so that's basically the single change. It's the same template below. If we look at these update functions, what we have is we start a transition, which basically starts the period during which the optimistic state is applied. You then say, okay, I'm doing an update, so let's write this optimistic state. That gets displayed immediately. And then we have two promises here. One is the promise to send the data to the server. And then the second one is actually something that you can do with Electric, where you then monitor the replication stream to see the write coming through. And in this case, we're just monitoring on the row ID, which is the kind of simplest strategy. And so what happens is you then await both of those promises, and the optimistic state is applied until that promise.all resolves. And so this is a way of basically very quickly adding local offline write capability to the app. But the weaknesses of this approach are that the optimistic state is scoped to the component, so it's only available kind of within this context here, and also it's not persistent. So if you had something like a component unmount because you like navigated away or you refreshed the page, you would lose the local writes. And so the next pattern just basically again extends this a little bit with shared persistent optimistic state. So at this point you start to get really a bit more of a serious like local first pattern where you save local writes, they are actually persisted locally in local storage, and also the optimistic state is available across your application to multiple components. And if we look at it here, it's only a few lines of code on top of the previous example. We use this Valtio library for the local reactive store, and we basically just read and write out of local storage. You could obviously do more sophisticated things to have more granular updates in and out of local storage. This is just a trivial example. And then we've extracted out a little bit of logic, like here's our kind of add optimistic state function, which just sets the optimistic state. This is a function where we've pulled out that logic to monitor the replication stream for the write coming through. And because this is a little bit more of a serious example, we also upgraded the merge logic. So in this case, we added a write ID column to the data model, and then that actually syncs through. And so when you're monitoring changes that come through the replication stream, you can look for your specific write. And the key difference there is that that allows you to rebase the local state on top of concurrent updates from other users. So instead of like somebody else updates the same row, you remove your local state. In this case, you know that it's your change that you remove the local state for. So it shows you how you can just sort of actually just incrementally have slightly more sophisticated merge logic. And then another aspect of this, just in the next function, we've abstracted a function out for this sort of sending the data to the API. And also in this, we monitor that request. And if it fails, we clear the local optimistic state. So the two key complexities with this type of stuff are the merge logic about how you handle concurrency and rollbacks when things don't work. This is obviously a naive strategy, but it's not as naive. You can do a very naive strategy, which is like clear all local state. In this case, we're like clear that particular write that was rejected, but you could kind of choose basically how much you want to bite off around implementing sophisticated rollback stuff, where in the real world, these kind of like concurrency edge cases and rollback scenarios are fascinating and a wonderful rabbit hole to go down. But like, for example, the first talk at the last meetup that we did last year was Adam Wiggins talking about his experience running Muse. So Muse is one of the largest like deployed or most used local first applications, or it was at the time. And his feedback in that talk was, actually, we don't get conflicts. So he built a whole collaborative whiteboard app with like lots and lots of people using it. And even for that application, he was kind of feeding back going, look, these things are pretty rare and an edge case. So you obviously, if you really are trying to build a high quality collaborative experience, and you really want to get into this stuff, there is obviously a lot of value there. But if your particular application is comfortable with patterns like just wipe the local state if there's an error, or like if the permissions change, lock them out, then you can go an awful long way with just like very, very simple code here. None of these things are more than like a couple of hundred lines of code. So anyway, that's just kind of walking through what's upgraded since the last optimistic state example. It's the same use state. If you look at the way that you merge the merge logic, it's exactly the same logic. It's just like we get a snapshot of this local store and we do exactly the same kind of thing in a plain reduce function. And then these kind of functions here are basically exactly the same. Do the write, have two promises, wait on it. So that's like a third pattern where we've already now got to a really quite sophisticated like local first pattern, offline writes, decent concurrency logic, explicit rollback handling, again, just using these standard primitives. The last example goes just to the next level, which is much more purist, which is like a proper through the database sync. So this is the same to-do application, but it's built with Electric syncing into PG Lite as a local embedded database. And if you actually look at then what happens with the actual same code here, it's extremely simple. We have a wrapper function here where we just set up the PG Lite client, and we also we've extracted the logic to send changes to the server to another utility. But then for the actual component itself, you sync data into the database, so you can bind the state into the application just using a live query, and these create update functions just talk directly to the local database. So this is the whole premise of local first, of like the actual application code gets simpler, and you move a bunch of the complexity out into some local schema definition and the external sync utility. So, I mean, I won't go into so much detail just because of time, but the pattern here is the one I was talking about before, where you sync into an immutable store, and then you have mutable local state. So we have a immutable table to sync into in the database, and then a shadow table, which is mutable. We combine them into a view, so you can just read and you can do live queries as if it's a unified table with the local state applied. And then we have triggers for both deleting the local optimistic state, and also we have these instead of triggers for basically saying you write to the view and it redirects the write to the local mutable table, and it also captures a change record into a change log table. And then what happens in this sync utility here is it basically just uses PG notify to say, hey, some data has changed, and it just sends it to the server. And if you look, for instance, at the API side of this application, it's a very simple Express server. We have these functions. This is on the server side to basically write into the database, and you have like post, put, delete methods to create, update, delete the to-do. And then also down the bottom here, we have like a thing where we can say post, you post transactions, transaction contains change operations, and those are written. And so that's like this function here is the back end of that kind of sync utility, where basically it iterates through the transactions and just writes them into the database. And writing into the database is just insert, update, delete. So in reality, even though this is doing through the database sync with sophisticated rollbacks and merge logic, the complexity is abstracted into a local database schema, and the sync utility with all of the sort of resilience and various sort of control flow is 200 lines of code. So I'm just going to fire these up. Basically, this example just runs these things in the page together. And so here they are. You can basically play around with this thing, and the data just syncs, and they all behave in the same way, kind of as you would expect. So you can kind of edit all of them. What's maybe interesting is looking at the behavior without the network. So if I go into the network tab and I switch to offline, we have a resilient client, so if I do a change here, it will keep trying to make it, but it doesn't sort of show any useful changes to the user. If I go to the optimistic state one, it's immediate. That spinner is kind of when that transition is resolving, of kind of showing when the data is coming through. The shared persistent one is exactly the same, and the through the DB doesn't actually need the same kind of mechanism because it's already persistent in the local database. And then if I flick the throttling back on, they all come through and they're eventually consistent and stuff in the right order. So basically, you know, the wait there is just waiting for the backed off fetch client to kind of get to realize that it's reconnected and send it through, and then it all just comes through instantly and you can interact with it. So basically what we've got here is these four different patterns, 3 of which are proper patterns for building local first applications, just using a very standard Express API just on top of read path sync. And of course, because I did the gatekeeper auth example to begin with, what I did here was I went and grabbed, I was showing you the stuff in curl, but if you look at we have a little client here that shows you basically, this was like make a request to the gatekeeper, return that config to the shape stream. So we can like pass in the auth headers when you're establishing the shape subscription, and it has a little on error callback so that if the token expires, you can do a request again to get an updated one. And so I just grabbed that code, I stuck it in the shared config over here, and I hard-coded the right URLs in this to-dos table. And so actually all of these write pattern examples running here, if we go back into the browser console, they are, so if you have a look at like some of the requests going on, you can see the first request is to this gatekeeper endpoint, which is returning the bearer token, and then all the subsequent requests are going via the proxy and are being authorized by the proxy. So again, these are local first applications just built using standard primitives that are both with authorization and local first rights. Yeah, so I mean, that's basically kind of where I wanted to get to on this. One quick thing just to flag up is that we do have a blog post which kind of covers a bunch of this in more detail. So these kind of the auth patterns and the write patterns are documented on the site, and there's a blog post here which kind of runs through this, including a bunch more stuff like encryption patterns and stuff in detail. And basically, this is what I wanted to leave you with as a takeaway, right? So we started with that powerful idea that local first can eliminate your API, but actually what I want to leave you with as a powerful idea is that you can develop local first applications today just using your existing API. And you don't need to reinvent your stack or cut out all these integrations, just as you don't need to reinvent sliced bread in order to make toast in the morning. Thank you.